Hello gang, this is just a video tutorial on WebMachinist 7.6. This is the latest version of the WebMachinist software program. This is a great software program for helping out with various calculations in relations to CNC programming and CNC machining and even general manual machining also. I just want to go over some of these things real quick. This is the main menu of WebMachinist. These are all buttons that'll get you quickly into certain areas of the program, and also you can also go under the calculators menu, and that will also get you into a lot of the different areas of the program. And there's also a reference section. We have blueprint symbols, the drill index, screws, machining formulas, that sort of thing, tap drill sizes, tapers, what have you. So anyway, start over here with a simple lathe cam. This is a tooltip radius compensation program for lathes. Go in there, you can either do OD, tooltip radius compensation, ID, tooltip radius compensation, or even a cutoff tool compensation. Let's take a look here at the OD, give you an idea. Let's say these are the different scenarios, very common in CNC machining that you might run up against that you would like to have the tooltip compensation calculator for you. Let's try this one. When you click on one of the scenarios or one of the tools, it'll ask you, do you want to calculate the compensation with the G-code programming or just the tool radius compensation with no G-code? Let's try G-code. And in here you just put in the variables. In this case, the angle is 30 degrees. Tooltip radius is 0.0156, which is 1/64th, very common. The X drawing position is this calculated point right here. Drawing position X, in this case it was 1.250. The Z drawing position is minus 0.500. And if you want to put a radius right in here, in this case a corner radius, you have that option here. You don't have to, but if you do want one, you can put it in there. Down here you can choose the direction of the feed. This is a typical going from the front Z towards the rear of the part, or you can also go the other direction just by clicking that arrow there, and that'll change the direction too. You have the option just use R for the radius in here. A lot of machines now, that's all you need to put in, or you have the option to use the I and K values for the radius. I usually like to use the I and K. And then you just would click calculate, and based on all these numbers you put in here, it would calculate out this program right here. So you've got your G1 or the feed to, that's up to this point right in here. And then it would G3 form that little radius, and also all the tooltip radius compensation is all built in there too. And then you have the option down here, you can print out this program, copy it to your computer's clipboard so you can paste it into another program. And when you're all done, just hit done, and you're back to this menu here. The ID is the same type thing, just choose a tool with or without G-code programming, and then you'd fill in your variables for that particular tool radius compensation you're trying to calculate. The cutoff tool calculator is something pretty new to the WebMachinist. It's kind of neat. Sometimes when you're going to cut off a part, you may have to form a chamfer on the backside, and it's nice to be able to calculate that based on your tool radius on each corner of your cutoff tool right in there. So in this, just like the other one, you input all your variables, the radius of the part, the X start point, Z start point of where you start to cut off, the Z endpoint where the part is going to be cut off to, in this case it's minus 475. Again, you have an option, if you want to radius these two corners, you can. In this case, it's got a 25 thousandths optional radius in there. And again, you don't have to put any radius, just leave sharp corners. Use the I and K for the radius, or use R for the radius if you have a radius in there. Your tool width, 0.125 in this case. Which side your offset is set on, either the right side or the left side. And then the the radius on each corner of your cutoff tool, in this case 7 thousandths, and then you would just click OK, and it would put in all these dimensions and what have you, and then also make your program right here to cut it off, to at the proper angle, to form a radius here on that corner and on that corner. And again, you can just copy that to your clipboard or paste it to something else, or you can print it out. Okay, going back to the main menu of WebMachinist. Next menu over is the speeds and feeds calculators. All kinds of good stuff in here. You got your machining speeds and feeds for turning, drilling, milling, tapping. You got your feed rate conversions, which is a lot of good stuff in there. Your rotary access feeds, feeds and speeds conversions, a whole bunch of different conversions in there. Spindle speed, a straightforward spindle speed conversion calculator, and then feeds and speeds formulas with calculators included. Let's look at the machining speeds and feeds over here first. This one you can choose turning, milling, drilling, threading, or tapping for your feeds. Let's just go ahead and for demonstration purposes, pick turning. It's going to ask you, okay, what kind of material are you turning? With all these different ones in there, pretty much covers most of the ones that you're probably going to be running across. Let's say we're going to turn alloy steel. Click alloy steel, say OK. Now it gives you all the different groups that are available in here. And let's say we're going to be turning 4320. Click that. Now it's going to ask what's the Brinell hardness of the material. Let's just leave it at 125 to 175 Brinell and click OK. Now it does all these calculations for you for different types of cutting tools. For instance, uncoated carbide hard. It'll give you the surface feed, in this case 705, and a starting point for turning in inches per revolution, which is would be the roughing. And again, same thing for uncoated carbide, a tough grade. In this case, it'd be 320 surface feed, a feed rate 17 thousandths per revolution, and so on and so on. It goes through coated carbide, hard, coated carbide, tough, ceramics, 3 different ceramics in this one. Even high-speed steel is included in there. There also is, in each one of these, a couple of little calculators, just if you need to use them. In this case is a surface feet per minute to revolutions per minute calculator. You just put in your surface feet, let's say 300, and the tool or stock diameter, let's say it's a 1/2 inch, and it'll calculate the RPM for you. Same thing on this side. This side is inches per revolution to inches per minute calculator. Pretty straightforward stuff. When you're done, just click done. You can, same thing for milling, drilling, threading, tapping, for different materials. Going back to the speeds and feeds main menu. Here's feed rate conversions over here. You've got all these different choices. For inches per minute, inches per revolution, inches per tooth, for instance in milling, that sort of thing. Inches per revolution to inches per minute to inches per revolution, and so on and so on, inches per tooth to inches per. Let's just click one of these and so you get an idea. You just go ahead and click one, whatever you're interested in, and this little calculator will come up. Let's say your inches per tooth is 2 thousandths per tooth. And the number of flutes or teeth, let's say it's got, let's just say 24. And it's going to calculate out inches per revolution is 0.048 inches per revolution. And it'll give you a couple other calculations in there as well. They're all pretty self-explanatory. Inches per revolution is how many inches per minute. Let's say we're going 25 inches per minute at an RPM of 6,000, and it's going to calculate our inches per revolution based on 25 inches per minute at 6,000 RPM, and so on and so on. Pretty neat when you're trying to do conversions from one form of feed rate to another. Works out really well. Now going back to our speeds and feeds main menu again, we also have rotary axis feeds. This comes in real handy if you're doing 4th axis work. Once again, just pick the one that you think you're going to need and just click on it. Here's inches per minute, 2 degrees per minute. Let's just click that one. Let's say inches per minute. Let's say 20 inches per minute. And the diameter of the cut, let's say we're on the 4th axis and we're making a cut at 1.5 inches diameter. Maybe the stock or whatever is 1.5 inches in diameter, and that's what we're cutting. And then say OK. And it's going to tell us what the degrees per minute is. And as you know, in a lot of 4th axis work, you have to program it in degrees per minute. So 20 inches per minute cut at a diameter of 1.5 inches on the cut would translate into 1,527.888 degrees per minute. Pretty easy, but a nice handy feature. You can also do, for instance, this one, degrees per minute to inches per minute. Let's say you're doing 197.5 degrees per minute, and the cut diameter, let's say, is 1 inch. And that's going to translate to 1.7235 inches per minute from degrees to inches per minute. Okay, going back to see what else we've got here in the speeds and feeds. Here's another good one, feeds and speeds conversions. This is pretty interesting here. Lots of them in here. Too many to go over in this video, but you'll get the idea. Surface feet per minute to revolutions per minute, RPM to surface feet per minute. Inches per minute to inches per revolution, inches per revolution to inches per minute, inches per minute to inches per tooth, inches per tooth to inches per minute, inches per tooth to inches per revolution, and inches per revolution to inches per tooth. That's all on the inch conversion side. Come over here, you got the metric conversion side. Surface meters per minute to revolutions per minute, revolutions per minute to surface meters per minute, millimeters per minute to millimeters per revolution, millimeters per revolution to millimeters per minute, millimeters per minute to millimeters per tooth, millimeters per tooth to millimeters per minute, millimeters per tooth to millimeters per revolution, and finally millimeters per revolution to millimeters per tooth. And these are all really self-explanatory. Just pick one here, show you kind of what you're doing. This one, inches per minute to inches per tooth. Let's say you're going 27 inches per minute, and revolutions per minute 4,500. And let's say you've got a 4-flute end mill. And it's going to give you all these calculations here. As you can see, even tells you the conversion, how to convert it, and a couple other additional calculations here. Come on over to the metric side. Let's try some of this. RPM to surface meters per minute. Put in the RPM. Let's say it's 6,000 RPM. And the tool or stock diameter in millimeters, let's say it's 30 millimeters. And that'll give us our surface meters per minute. So there you go. Easy stuff. Makes it a lot easier. 565. Going back to our speeds and feeds main menu. This is just a very basic, if you just want to do a quick conversion, spindle speed conversion. This is a real simple one here. You can calculate surface speed in surface feet per minute to RPM, and then RPM to surface speed. You can do it in US units, inches, or metric units, either way. Like I said, it's just a very quick down and dirty, quick calculation. And Finally, in these speeds and feeds calculators, we've got speeds and feeds formulas. This will give you the actual formulas for a lot of these things. And there's also a calculator built in here if you want to apply the formulas. Like, for instance, here, cutting speed formulas. These are the actual formulas. This is what each item means. The formulas, RPM, everybody knows that, revolutions per minute, SFM, surface feet per minute, and SMPM, surface meters per minute. And then here are the actual formulas here. For instance, surface feet per minute is 0.262 times the diameter, either the tool or stock, times the RPM, and that'll give you the surface feet per minute. Also, when you're in any of these formula areas, this little calculator up here, all you have to do is click that, and whichever one of these that your formulas list that you're looking at, this calculator, you can apply it in this calculator right off. For instance, this one, calculate the RPM, tool or stock diameter, say 500, and let's say surface feet per minute, let's say 250, and it calculates out the RPM for you. And that's the same with any of these things. Degree conversion formulas. These are all formulas for doing various degrees conversions. As you can see, there's quite a few in here. Got the formulas here. Converting radians to degrees. There's the formula. Converting decimal degrees to minutes and seconds. Here's the formulas. Or you can go up here and use the calculator. For instance, you want to turn degrees to decimal degrees. Say degrees is 35 or 33 degrees. Let's say 14 minutes and 37 seconds. So what is that in a decimal? Let's see. There you go. That converts over to 33.243611 decimal degrees. Okay. And degrees to radians, decimal degrees, 2 degrees, and radians degrees is also in this one. There's other ones, drill point formulas. You can also calculate, use the calculator, do that. You can use the standard sizes or put in your own custom angle to get the drill point depth. What else we've got in here? Feed rate formulas. Again, there's quite a few in there, converting all these various things to, like, so for instance, convert inches per two to inches per minute. There's the formula. Also, too, you can also use the calculator right here for all these too. Just click done when you're done with that one. Metal removal formulas. This is helpful for quoting. For instance, time cutting in minutes, time cutting in seconds, inches per minute, so on and so on. Time cutting in minutes, you just have to apply the formulas and it'll give you how long it takes to make a cut, that sort of thing. Again, it's also a calculator. Time cutting in minutes, let's, for instance, the length of cut. Let's say you're cutting a 24-inch length and you're going at 15 inches per minute, and take you 1.6 minutes to make that cut. So pretty self-explanatory, but you know, nice little feature. Tapping formulas. All these are calculating the tap drill size in this case for inch cutting taps, calculating the tap drill size for metric cutting taps. If you want to calculate the tap drill size for fluteless or roll forming taps, there's the formulas there. Same thing for metric fluteless taps, there's a formula there, or you can use this little calculator too to do the calculations for you. And true position formulas. This is the true position formula that we're all probably sort of familiar with, but not too many people know this, how to apply this formula, and do not know it by heart, so it's nice to have the calculator. And actually in WebMachinist there is, under the inspections calculators, there is a true position calculator just to do that. But you can also use this one here. True position only, or true position with maximum material condition. That's in there too. And it'll ask you things, variation from drawing, the basic, and the variation from the drawing dimensions on your Y, the whole size basic dimension, X, et cetera, et cetera. And well, you have to put something in there, otherwise it's going to give you an error. But anyway, I'm trying to keep this thing moving because it's a lot of material here to cover. So go back to the main menu. Here's a really neat feature of WebMachinist 7.6. Drill Pack deep hole drilling calculators. Now if you do any deep hole drilling, either on the lathe or the mill, this is an awesome calculator, and I'll show you why. Let's go to the mill drill pack. They both operate the same. One is just for the lathe. It has the same functions and everything as the mill does too. So in here, what you have is this is a drill, mill drill. Is you have these three different options. The first one is same peck at the full depth. Now this one really you probably would never need because you'd use like your can cycles, things like that. But what makes this one a little bit different is you not only do it, you give it all the usual parameters. For instance, how deep you're going, the Z clearance point before you start drilling, your peck amounts, your feed start, usually that's Z to 0. This one you can also program in or tell it to calculate after each peck how far to go back down to the hole and then stop before it starts drilling again. So in other words, whatever the last peck was, it'll stop. In this case, it'll stop 15 thousandths short of that and then start to feed again. What makes this one, even though it's the same peck all the way down, is you have the option to put dwells in, and you can put a dwell in after every peck, or you can put a dwell in after some of the pecks. So if you wanted to say after 3 pecks or after 13 pecks, up to you, and then how much of a dwell you want. It'll get to that point, and then it'll start dwelling when it comes out of the hole, and that's good for washing away chips and things like that. So that's this one, the same peck full depth. Now it gets a little more interesting. This one is reduce the peck at a partial depth. So what this one does, you still, just like the other ones, you tell it how deep you're going to go total, your Z clearance position, your feed start position. In this case, you tell it your initial peck amount, how much the first peck is going to be. Also, you give it a minimum peck amount because this one's going to reduce, once it hits a certain depth, it's going to start reducing the pecks once it gets down in the hole a ways, depending on what you want. And then in here, you got the option to tell it how much to reduce each peck by from that point on. So in this case, it says reduce peck Z start depth. That means when it gets to this point, minus 632 into the hole, remember it's going 3 inches deep, it's going to start reducing the pecks from that point on. And that's where this comes in, right above it, reduce each peck. So it's going to start reducing each peck by 15 thousandths until it gets to the full depth down here, or until it reaches this minimum peck amount, which is 25 thousandths. It's a really cool calculator to have for default. It just breaks the chips up really well based on, what you're trying to do. Also here you can put in dwells after all the pecks. You can dwell after some of the pecks. It's just really, really helpful. So once you've got all that in there, it's okay, and it'll make your program right here. And you can color code it, make it a little easier to read. And as you can see in the program here, it even tells you when it starts reducing the pecks. At this point right here, you can see the dwells in there, and that sort of thing makes it real nice. And you can either print that or copy it to your clipboard and paste it into something else. Now the last option here, which again this also works for the lathe too, I'm just showing you the mill example, is reduce the peck each pass. So again, you've got your same parameters you have to put in, how far you're drilling, what's the depth, your clearance planes, your feed start position. In this case, you got your initial peck amount. Now this one's going to reduce the peck each time all the way down. So you're going to start off one, in this case, 125 thousandths peck. And you're going to tell, okay, well, what's the minimum peck amount? I don't want it to be ridiculously tiny when it gets to the bottom. So I'm going to say at least peck 12 thousandths. That'll be the minimum. And then how much to reduce each peck by from that initial 125 from the first one. So you're going to reduce it 1 thousandths each peck in this case. You can put in whatever you want. Return amount after last peck. That's just how far away from the last peck that you want it to stop before it starts to feed. Again, that gives you a little chance to get some coolant down in there if you need to. But you can put it anything in there you like. Again, you control the dwells. You can dwell after all the pecks. You can dwell after so many pecks if you want. The length of the dwell, of course, in this case it would be 1 second. And you know, your feed rate. And if you want to show the peck amounts in the program, we got that option here too. And just say okay, and here's your program here. And you can see that it's the reduced peck amounts are here. So the first one went minus 125. You see the next one stop. Remember, because we had 1 thousandths. Reduce it 1 thousandths each peck. So 124 is the next one, then 123, and so on, all the way down until it's finished, that part. And then the dwells, easy to spot in there too. And let's see. You can, let me just show you really quick. Here's the lathe. It's the same thing. Reduce peck each pass. Reduce the pecks at partial depth. Reduce peck at full depth. It's the same kind of parameters. Just looks a little different because this is on the lathe. It's all just like on the mill. Okay, going back to our main menu. Here's another really neat calculator, or calculators in this case, for milling soft jaws. I use this one a lot because I hate getting on the CAD system and drawing up some soft jaws for a part. I just go in here and it's a piece of cake. Right now it's just got the mill soft jaws, so just click the mill jaws. And you've got all these options. For instance, if you want a left stop, like what's shown here, I'll use that one quite a bit, where I just slide the part in up against here, and makes it real easy. I don't have to screw around with vice stops and things like that. You can also do a full rectangle, just gonna, or square. Part just gonna lay right in there. It's gonna be stopped all up in here. Or right stop, just like the left stops, that slide in from this way, stopping over there. You can also do no stop. You just want to mill some soft jaws, and you don't need a stop on either end. You're just going to stop externally with the vise or however. And then also you've got a circle, just for a round part, obviously. Let's do a left stop here. Just run through it so you can see how it's done. You just put in your jaw length. This is the total length of your jaws, just so usually it's like 6 inches. Your pocket width. Let's say in this case you want 3.5 inches. Whatever spacer you put between there, say 125 thousandths. Your pocket depth. Let's say you want to go down 500. It's you just put it as a positive number. You don't have to put a negative. Depth of the cuts, let's say 150 thousandths. What size end mill? Let's say using a 3/8 end mill, 375. Tool number, doesn't matter. say one. Your entry feed, how hard or how fast you want it to feed in before it starts milling the pocket. So each time it goes down in Z, it'll go with this. Let's say 10 inches a minute. And then your pocket feed rate, let's say 25 inches a minute. And then your spindle speed, let's say 6,000. And once you're happy with all your parameters, say OK. And all your parameters that you put in are here, and it's going to make the actual program here. Your first move is going to be a rapid point where it's going to start in, and it's going to go down a little bit above the jaws and start feeding from there. You also have the option to put in a header and footer. The header is just going to describe, in this case, what you already know, left stop jaws. There's a 125 spacer between the jaws. X equals the left end of the part, or the jaws, you can see right here. Y is going to equal the center, as you can see right there. And then this is size end mill. Now this is good for an operator. So now they know exactly what you're doing here. So they know that set their X and Y 0 right here, and what size end mill you're using. And you're good to go. And again, you can print out this program, or you can copy it to the clipboard or paste it into something else, you know, whatever editor you like to use, or into another part program as a sub-program for the jaws, however you like to do it. Okay, and that, like I said, that's a really, really helpful tool right there, this soft jaws calculator. Go back to the main menu, check out a few more things. Inspection calculators. We have a hole location calculator. It's just a real quick, easy calculator to calculate the actual measurement the actual dimensions of holes, depending on to where you want to measure them based on your measurements. Go ahead and take a look at that. You can calculate edge to hole without a pin in the hole. You can calculate the edge to a hole with a pin in the hole. You can calculate hole to hole between two holes, without any pins in there, or you can calculate hole to hole with pins. So they're really straightforward. Let's just try a hole to hole with pins. So first thing you put is your first pin diameter. Let's say it's 500. Using a 500 pin, and it fits in the hole just right. Let's say your second pin, say the hole's a little bigger, it can be the same size or a little bigger. Let's say that one's got a 0.750 pin in it. And now you're measuring from the outside. As you can see here, what you're measuring, you measure from here down to here, which is really easy to do with a height gauge. And let's say you're measuring, let's say 2.788 is what you're measuring between these two pins, the top of this pin to the top of this pin. Click calculate, and over here it's going to tell you what the actual dimension is between those two holes. There you go. It's actually 2.913. So it's just a real quick little thing. Put away your little calculator, you know, and just punch in a couple numbers in here and you're good to go. It works the same with these other ones too. This is an edge, you know. Put in your measurement from the edge of your part to the bottom of your hole over here. Put in your hole diameter. Let's say it measures out 500. Let's say you're measuring 1.963 is what you're measuring, and then it's going to tell you what that actual edge center of that hole is. In this case, 1.713. So easy stuff. Also in the inspection calculators, sign bar setup calculator, very straightforward. You'll get this screen here first with nothing on it, but you just come down here and choose either to calculate the gauge blocks you need to set the sign bar, or calculate the angle of the sidebar based on the gauge block. So click calculate gauge blocks. Put in your desired angle. Let's say you're trying to get an angle of 27.5 degrees, and your sign bar length. Everybody should be familiar with this. They're quite common is 5 inches or 6 inches. Let's say we got a 5-inch long sign bar. Click OK. It's going to tell you now what your block height is that you need to set this at the angle you're after, which in this case was 27.5 degrees. And these are the gauge blocks height you need. It's also going to give you a gauge block list, which is really cool. You don't have to sit there and try to figure it out yourself. You just, right here, it tells you need a 2-inch gauge block, a 0.100, 0.108, and then a 0.1007 to get that height. So very straightforward, really handy, saves a lot of time. You can also do an angle, calculate the angle that you're set at just by entering the gauge block. Like, let's say you got 2.3894 height of gauge blocks in there, and your sign bar, let's say, is 6 inches long. So based on the gauge block height you put and the length of your sign bar, it's calculated out what your angle is, what this is actually sitting at. So it's kind of handy. In this case, with that and with that gauge block height and that sign bar length, it's 23.4678 degrees, or converted 23 degrees, 28 minutes, 4 seconds. So very straightforward stuff. Let's go back to our main menu, go back to inspection calculators. You also have a dovetail calculator. Pretty straightforward. Just put in your angle, the width you're after, because usually this is what you're trying to obtain. Let's say you want a 2-inch width. And then the size pins you're going to be using, let's say we're going to use 312 pins, and then calculate. And then now it's going to tell you what your measurement across the pins needs to be to obtain this desired width at this angle. And of course you've already put in your pin size. So going back to our main menu again, back to inspection. This is just a gauge block calculator. This is almost like the sign bar setup calculator. In this case, you just put in the gauge block height you're interested, and then it'll just, oh, no, that didn't work. Okay, and then it'll just make a list of your gauge blocks for you. Probably don't really need this very often, but it's nice to have it in case you do feel like you might want to calculate a gauge block list this way. Okay, going back to the main menu. True position calculator. This one comes in pretty handy sometimes. I hate figuring out true position. I know a lot of people do. This one, to calculate your actual true position, you just put in all your variables. For instance, this is a hole to an edge. Your measured X dimension, let's say it's 2.502. The drawing X position, which is actually what it's supposed to be, your blueprint dimension, let's say that's supposed to be 2.500. Your drawing Y dimension, again, the actual, let's say that's supposed to be 1.875. And we are actually measuring, let's say, 1.8785. Okay. And our hole diameter, our drawing hole diameter, which is on the drawing itself, let's say they want a 1-inch hole. Tolerance be the minimum and the max. Let's say the minimum 998 according to the drawing, and the maximum, let's say 1.002. Okay. Here we put what we actually measure the hole to be. Let's say we're actually measuring to be 0.9995. And down here you can put just the true position only, or true position with maximum material condition, or a lot of people like to say true position at maximum material condition. And then in here you put your maximum material position tolerance according to your drawing. Let's say they tell you it can be maximum 0.008. Say OK. And it's going to tell you, it's going to calculate all your variables out for you. What your drawing true position was 0.008 at maximum material condition, and what your actual true position is based on the dimensions and everything is 0.0066. So you're within tolerance, which in my book is a good thing. I'm sure you agree. But anyway, that's how the true position calculator works. It's real handy, real time saver, especially if you're doing several to many holes that you have to true position out to make sure you're in tolerance. Okay. The last thing on the inspection calculators is the thread 3-wire calculator for measuring threads. We're all familiar with that to measure pitch diameters with 3 wires or 3 pins. You can do them for 60-degree UN and metric threads. There's a calculator for 29-degree Acme threads, and there's also one for 30-degree trapezoidal, which are metric threads, metric trapezoidal. Let's take a look in here. This is a 60-degree three-wire measuring calculator. As you can see, you've got these different calculators. Like for instance, you just want to find out what wire size is the best one to use. You just choose the pitch. Let's say it's something 16, and say OK. And it's going to tell you the wire size to use is 40 thousandths over that. There. So now other calculation make us calculate the measurement over the wires. So let's say you've got a 24 pitch. Yeah, let's say the minimum pitch diameter is 1.062. Maximum 1.072, let's say. I'm just pulling these numbers out of the air. I don't know if there's even any such, but just to give you an idea how this works. Say OK. It's going to tell you what wire size to use. Of course, your desired pitch, which is probably right off of your specifications, 1062 to 1072 nominal, which we know is right in the middle. These are your minimum measurements over the wires and maximum measurement over the wires to be within this tolerance. So you want to be 1.1129 inches to 1.1229 inches to be in tolerance. And again, over here you can see across your micrometer calipers, this is where you'd have to be in your measurements to be within tolerance. So easy stuff. Last one here, calculate pitch diameter using wires. In this case, you tell it what the thread pitch is and what you're measuring over the wires now. So let's say you're measuring 2.065 over your wires or pins. And now it's going to tell you what your pitch diameters are. So you should be using a 32 thousandths wire size. Here's your measurement over the wires. Also over here is what you measured, 2.065 inches. And it's calculated out what your actual pitch diameter is, in this case 2.0171. So that will tell you what it actually is. Very, very handy. Nice. And all these, it also applies, you can do it for metric threads, the 29-degree Acme threads, and the 30-degree metric trapezoidals also. Same thing. Put in your variables and it'll calculate all that, just like it did for the UN. Okay, going back to the main menu. After inspection calculators, we've got bolt circle calculators. In here you can calculate the points for full circles partial circles, polar points. There's even a chord to diameter calculator, and there's even a wheel bolt pattern calculator in here. I'm not going to go through all these because it's going to take a while, but you get the gist of it. Let's just take a quick look here at one. Yeah, just put in the number of the holes, the bolt circle diameter, the angle to the first hole right here. In this case, it's just 0. The center point of your pattern, whether or not you're doing a full circle or a partial circle, if you're doing it in inches or millimeters. So just go ahead and do that. You can do up to 100 holes on this circle. And it's going to give you all your parameters, and then here's the points. And these points also correspond to these numbers. So like if you're wondering, okay, what's number 14? You can just click it right there and it's going to tell you. And also it's down in here, right there, X and Y position. And again, you can print those. You can also save it to a file for editing. Or you can copy it to the clipboard on your computer and paste it into a program or something. I just want to show you wheel bolt patterns here. This probably not something you're going to use often, but it's kind of neat to have it if you are trying to figure out the bolt pattern of, say, your vehicle or something. And let's just go with the 5 bolt here. All you have to do is tell it the stud diameter or the hole diameter in the wheel itself, and then just measure across the studs or the holes. In this case, it's 4 inches, or you can do it by millimeters. And click calculate, and it's going to tell you the bolt pattern right here. In this case, it worked out to be a 5.5292 bolt pattern for a 5 bolt pattern. So very self-explanatory. The threading calculators. Let's go through these real quick. On here on the main menu, you can do the 3-wire we already looked at. There's also tapping formulas, a tapping calculator. You can choose your thread types. In this case, unified, which we're all very familiar with. You just pick the thread, and it's going to give you all these dimensions and variables and other things that go with it. You can see your major diameters, minor, your max pitch diameter, minimum, minor diameters, feed rate if you're single pointing it, in inches per revolution, and also in millimeters per revolution. Your 3-wire pitch diameter measurements, the wire size, etc. So this is for the OD threads, obviously. Over on the ID side, it's going to give you basically the same thing, but over here it's going to give you a cut tap drill size and a form tap drill size, plus all your other dimensions for an ID thread. So a lot of good information there, really quick. It works also too for metric threads, metric trapezoidal thread, same thing. You just choose your thread, whether it's ID, OD, and it's going to give you all your dimensions right there like that too. The tapping calculator here, you just kind of like the threading, choose your size. This one's also going to give you tapping speeds and feeds for different materials, as you can see down here. Drill sizes, feed per revolution, etc., etc. Also works for roll taps. Same thing, speeds and feeds, and drill size, what have you. You can also do custom taps, custom cutting taps. This is kind of interesting. Where you put in, for whatever reason, say you have to build a custom tap for some reason, and in this case, let's say you want to do a 0.275 diameter tap times 23 threads per inch and 75% full thread. I can't imagine ever doing a tap that size with those variables, but you could potentially. Same thing, gives you all the information just like the other ones. You know, your calculated drill sizes in there, your feed production, your speeds, and what have you. And you can do custom taps for roll form taps too. And this all applies to metric taps too. There's even helicoil taps you can calculate it out to. Okay, let's see what else. Did the machining formulas and calculators. We pretty much went over these already when we were doing the speeds and feeds, so we really don't need to go over this one again. Metal weights. This is interesting. This is helpful for quoting. Let's say you've got a job coming in, and let's say it's let's say you got some aluminum. You're going to do some aluminum. So you choose aluminum. Now let's say you got to choose an alloy. Let's say we're going to use 7075, and we're going to do some rectangular 7075. Click rectangular. The width, let's say it's 1 inch, and the height, let's say it's 2 inches. So it's 1 by 2. Let's say we're going to do a 12-foot bar, which is 144 inches, or we could make it 12 feet. Change that to feet. Let's just go 144 inches. If you know a price per pound, it's optional. Put that in there if you like. Let's just say it's $3.25 a pound, or something like that. And just hit OK, and it's going to tell you the weight for the bar, 29 pounds, and what the cost would be based on if that was the actual price, 29 pounds. And you have these different shapes. You can do round, rectangle, square, hexagon, or even round tube for all these different materials over here. So like I said, it could be real handy for quoting purposes. Nice calculators there to help you out with some of that. Smart drill index. Now you're probably wondering, what the heck is a smart drill index? I would think a drill index would be kind of stupid, but I'll show you. Okay, it's got all your sizes of different drills, your fractional drills, your number drills, your letter drills, and your metric drills. Just to show you why this index is smart, let's say, well, I'm going to look down here at fractional drill, and I am going to choose a 7/8 drill. So I'll click on 7/8. Now what it does, this is the smart part, for 7/8 drill, Smart Drill Index is bringing up all of these different materials, and from there it's giving me my speeds and feeds, RPM, based on what alloy. For instance, all these are alloy steels. Just go and find the one that you want, Sprinell, inches. It'll give you the inches per revolution, even inches per minute, for instance, if you're on the mill or what have you. And this is all for a 7/8 drill. Go down to aluminum. Aluminum's pretty basic, that's why there's only 2 lines in there. Copper alloys, the different types of copper alloys in there. It's just loaded, I mean loaded with speeds and feeds for all these different drills. Carbon steel, stainless steels, tool steels. Just a really neat thing to have. And you can print out this whole thing if you want. Just say, okay, get out of there. Like I said, it works for any size drill that's in the list here. That's a really nice, that's why it's a smart drill index. Center drills and countersinks calculators, just basic stuff like, okay, number 10 center drill, here's the dimensions of it. This one down here, if you want to make a particular countersink diameter using a center drill, you just choose the center drill size and then what size of the countersink you want to make with that one. And if it's within that parameter of that center drill, it'll tell you. So you'd have to go 0.3173 deep to make it 0.275 countersink with a number 5 center drill. So like I said, pretty basic, but it's handy takes the guesswork out of when you're countersinking with a center drill. And the dimensions up here also is nice to know, because you don't always know right offhand or have right at your fingertips the size of the center drill, and this is a good way to just to go see what will work for you. Let's see what else. Trig and geometry calculators. Usual stuff, right triangles. What's interesting about the right triangles in here is there's all these different layouts of right triangles. So if you're transposing direct off a drawing or off of a problem, it's kind of neat not to have to calculate the triangle out and then kind of flip it around to see how it affects or how it works with what you're trying to see. This one you can just go in and, oh, that's exactly what I'm doing, and put in your usual information to solve a right triangle. And it fills it all out for you. And you can print this out. And like I say, you got all these different ones you can do. Going back to the trig and geo, circle segment calculator. If you need to calculate any of these things, like for instance, this case, an angle and a radius is known. Let's just see what that would do for you. Let's say the angle, and you can see right in here, is 47 degrees, let's say. And let's say the circle radius in this case was 0.520. You know, it's going to tell you all the information it can gather for you, calculate out, in this case, the chord length, and then the height, chord height here. It also gives you the arc length, circumference, circle area, and circle diameter. And kind of neat. Saves you time if you do have run across where you do need to calculate these kind of things out. And again, you can chord length and height, they're known, radius and height, they're known, and it'll give you similar calculations. Going back to our trig and geometry calculators is area calculator. You can calculate the area of a circle, a square, a rectangle, or a hexagon. Very basic. For instance, hexagons, put in the hex size, say it's a 2-inch hex. And that's going to give you not only the area, but in this case of a hexagon, it's going to tell you what it is across the flats, what it is across the two opposing points here, the area down here, of course the width of the flats, and across the points. So, a circle, tell it a circle diameter, say a 3-inch round or circle. It's going to give you the area, of course the radius, the circumference, things like that. So could be kind of helpful. The 3 points, I've run across this a few times. This is kind of real handy when trying to figure out 3 points, or the center point, excuse me, on a circle. So let's say you got 3 points, and you want to find out where the center between those 3 points is. So let's say point number 1 is x of 1 inch. Let's say it's y of 1 inch. Let's say you got another point. It's x minus 750, y is minus 250, let's say, and you got another point on here, and let's say that's x of 0.2, and let's say the y is minus 875, or you know what you measured out, or however you did it. Based on these 3 points, it's calculating out the center right here in between these 3 points, wherever they happen to be. In this case, the center of the circle is telling you right here, and it's also telling you the circle radius right here. And again, you can print that out. Okay, moving on. Hope you're still with me. This one, hex corner points calculator. What this does And this could be kind of handy sometimes. Put in a hex size. Let's say we've got a 7/8 hex, which is 875. So you got to put in. It's going to calculate out each corner point of that hex. See? So each corner point, and it's going to put them all right in here, their positions. And that could come in handy if you need to drill out corners to make a hex fall into a mating piece or something like that, or you just need to know where those are. This is how you do it. Real easy. You don't have to sit there and get out your calculator and trig all these corner points out. Calculates it right there for you. Very easy. Okay, moving on. Metric conversions calculators. Very straightforward. On one side you got your metrics, let's say cubic meters. Once you click on one on this side, it'll show you the other conversions you can convert that into. And let's say cubic meters. Let's say we want to change it to cubic yards. How many? We want, in this case, 66. That sounds fine. Now it's going to tell us that 66 cubic meters converts to 86.3214 cubic yards, etc. Like I say, just pick any of these. It'll show you what the possibilities are. Anytime you want, just click Reset Conversion Tables. If you want to go the other way, choose an imperial side, say fluid ounces, and it'll show you what we can change that into. Let's say to liters. So let's say we want 100 fluid ounces. So how many liters is that? And it's going to convert to 2.84 liters. So you get the idea. Kind of handy when you need to convert imperial to metric, metric to imperial. Okay, going back to the main menu. Manual machine calculators. These are kind of helpful sometimes in the shop. These are actually suggested by one of my customers that does quite a bit of manual machine work and needed something like this. So I pretty much made these up for him. Lathe cross-side calculator. What that is, when you're going in at an angle that isn't perpendicular to your part, sometimes it's a little difficult to know exactly what you're actually in-feeding into the part. Like, let's say you're going in at an angle, but you want to take 10 thousandths off the part or something like that. It would be nice to know how far you're actually going in. So let's say you're going in at an angle, let's say 15 degrees. And your cross slide, let's say you're cross sliding every 10 thousandths on your dial. So we're gonna go, every 10 thousandths. I want to see how far I'm actually feeding in on the diameter. So on the diameter, I'm actually, even though I'm going 10 thousandths, but I'm at an angle of 15 degrees or 75, depending on which side you want to look at, even though I'm cranking 10 thousandths on my dial at this angle, I'm really only in-feeding on a diameter 0.0026 inches on a diameter. So that solves that little problem for me. So I know how far I have to in-feed this way to change on that diameter. And let's see, going back to the manual machine calculators, the tailstock offset calculator. Okay, this is fairly common. I've had to do a lot of tapers and things on a manual lathe, like one piece, one offset kind of thing. You can choose either taper per foot offset or angle offset. If you choose taper per foot, let's say your desired taper per foot in inches, let's say for every foot you want 1 1/4 inches of taper. And the length of the part, let's say, is 10 inches long. Click OK. So based on that desired taper per foot and the part length, this is going to tell us how far on your tailstock you need to offset it to make that taper. and in this case you'd have to offset at 0.5208 inches, and then off the center here in this case, and that would make it cut that desired taper per foot. Real handy to figure out. Also, you can use the angle offset, where let's say you know the angle and the part length. You don't really care about the taper per foot at this point. You just want to make a certain angle. Let's say you want to make a 23-degree angle, as shown off center here. And let's say the part length again is 10 inches, let's say. Wow, that'd be a that would be a huge offset. So that probably wouldn't be realistic, even though that's what it calculates out. Just for the heck of it, let's reduce that angle. That's a pretty big angle. Let's say you want a 1.5 degree angle at 10 inches. Yeah, it's a lot more reasonable. So your offset in that case would be 0.2619. So you just offset it into your cutter, and you'll end up cutting that angle over that length. Okay, going back to the main. I think this one's kind of interesting. I had a customer that needed this. I don't really remember what exactly he was doing, but he needed to know inside of a hex where an end mill would fit inside the corners. That's what this does. So calculate end mill points on this hex, put in the hex size. Let's say it's a 3-inch hex, and let's say the end mill diameter we're using a 1/2 inch, and click OK. And now what it's telling me is, based on this hex size, a 1/2 inch end mill, the center point of that 1/2 inch end mill would fit right in that corner at this point, these points right here. And it's calculated and listed them out over here for you. And again, you can print them, print it out, print this whole thing out, so you've got them. Like I said, I'm not sure why you would need this, but it could be something that in your shop might be useful. I know it was for somebody. Also, this one can also, just like that other calculator that we looked at a little while ago, can calculate the hex points, just points for you. 3-inch hex, let's say, just like the other one, and tell you those corner points. That can be handy sometimes. Okay, going back to the main menu, getting there. Something that was just added in the last version of WebMachinist was a spur gear calculator. Actually, 2 calculators in there. Imperial English spur gear calculator. All you have to do is input some known factors. Let's say number of teeth, let's say 12 teeth, whatever it happens to be. Diametrical pitch diameter, 250. What's your pressure angle? Choose any of those. And what it does then, it's going to calculate, based on that, it's going to give you all your calculations, your outside diameter, your pitch diameter, your hole depth of your teeth, root diameter, the addendum, dedendum, clearance, circular tooth thickness, circular pitch, and the base circle, based on what you've put in up here. That's for the Imperial. The module, which is the metric module calculator, very similar. Put in the module number, let's say 35. I have no idea number of teeth, maybe 24. Let's just see what that comes up with. Same thing. It gives you, based on the information that you give in the calculator, it's going to give you the metric module dimensions. In this case, the diametral pitch, circular pitch, and these are in millimeters. This is inches over here. Outside diameter, root diameter, pitch diameter, circular tooth thickness, the addendum, dedendum, and the hole depth. Pretty straightforward. And hardware, screws mainly is what's in here. Sizes for different set screws. In this case, socket head screws. Just click what it is and it gives you the dimensions and that sort of thing for it. Different screw types you can choose, button heads, flat heads. In this case, the flat heads even tells you the countersink, like let's say take an M8, tells you what you need countersink diameter you need to make to accommodate that. Could be useful, things like that. After that, oh, you got a lease and loan calculator. You can calculate a lease or a loan by the number of payments. Just click the amount, lease or loan amount. Let's say you got a $60,000 amount. Let's say the interest rate is 3.25%, and the number of payments, say it's 5 years, so 60 months. And if you want to create an amortization schedule, which I usually do, and it'll make a schedule for you. This is what your payments would be for 5 years, and it keeps a running balance and amortization schedule. How much of that payment went towards the principal, how much to interest, and how much your principal balance is, all the way down to the end, and you have your total interest paid and total number of payments and that sort of thing. You can also calculate by the desired payment amount if you like to. And let's see, up here under reference, there's a quick reference to blueprint symbols. Can come in handy sometimes. Smart end drill index, we already went by. Self-tapping screws, kind of like the other ones. It's got different self-tapping screws and what have you in there that there's really not a whole heck of a lot. It's just telling you common sizes or common slot sizes and tap drill sizes for them, that sort of thing. Socket head cap screws, went through tap drill sizes. It's just your basic choose your tap, and it's going to spit out your drill size for form taps or cutting taps, also for metric taps and pipe taps. Gives you the drill sizes for those. And last but not least is our tapers reference. In here, you know, a lot of us work with tapers. These are standard size tapers. If you want to know the dimensions of them, for instance, Morse taper number 5, there you go. There's your dimensions for Morse taper number 5, or say a Brown and Sharp. Yeah, let's say number 1, see what that looks like. There's your Brown and Sharp number 1, Jarno's, Jacob's tapers. Gives you your dimensions. You can also change these to millimeters dimensions too. Also has a capability of you inputting dimensions for custom tapers. These are all the various ones you can do. Like if you know the taper, or what is the taper angle when the taper per foot is known, what's the taper per foot when the taper angle is known, and so on and so on. You would put in your dimensions. Small n, let's say the taper per foot is 1.25 inches per foot. And let's say the taper length in this case is 10 inches. And then it does all the calculations for you of what that would work out to be. So pretty self-explanatory there too. Just read these, and there you go. So anyway, I want to thank you for watching this video, especially if you watched it all the way through. I know it was a bit long-winded. I go into more detail on some of these calculators. There's a lot still I couldn't even cover because there's just too many things in this program. It's a great program. It's a great utility program to have to assist you in your everyday shop practice. And I would encourage you to stop by WebMachinist7.com. I've got a lot of good information on there. And also how you can order WebMachinist if you don't already own it. And information and more formulas and things like that on there too. And hope to see you there. Thank you very much for watching the video, and have a great day.